systems of equations, solving by substitution. So today we'll be doing the third method of solving systems of inequalities. This one is known as substitution because we are going to be substituting something into another equation. So here's an example of how we would do that if we were given two equations. So this is the first equation that we're given, and this is the second equation that we're given. Notice that this second equation is solved for y. So I am able to take everything that y equals, so this x plus 5, and plug it right in for y. Substitution. Just like if y equaled, I don't want to write in a highlighter, if y equaled 2, you would all know, oh, I can easily plug in 2 for y and solve. We're doing the exact same thing, except instead of 2, it's something a little bit bigger, x plus 5. And then the steps to solve are very similar to what you already know how to do. You solve for x and plug it back into one of the original equations to solve for y. Okay, so refer back to those notes if you ever need them. Otherwise, let's solve the first example, and it's going step by step through each and every step that you need to solve this. So we're solving by substitution. Y equals x plus 1, and 2x plus y equals -2. So step number 1 is pick the equation that is isolated for either x or y. So isolated just means by itself. The first equation is already isolated for y. Y equals x plus 1. Step number 2, take your isolated variable and substitute it into the other equation for its corresponding value. Okay, so let's do that real quick. So we have y equals x plus 1. We're going to substitute it into the other equation. The other equation is 2x plus y equals -2. So I'll use my highlighter so you can kind of see what I'm doing a little bit more clearly. So y equals x plus 1. That's what y equals. I'm going to plug it right in for y. I'm taking this and plugging it right in. I will use parentheses just to kind of distinguish this is what I'm putting in here. So we'll have 2x, or let's write it below so we can see it a little bit better. So I'll erase that. We have 2x plus y. And what did y equal in the other equation? Well, it equaled x plus 1. And then that all equals -2. All right, so now let's solve that equation algebraically to get either x or y, or to solve for either x or y, whichever one you have chosen. In our specific case, there's only x left, so we're going to solve algebraically for x. So I have 2x plus x plus 1 equals I don't know what happened there, equals -2. I would distribute. There's not anything to distribute because there's just a 1 there. So I can actually just kind of drop my parentheses. So 2x plus x plus 1. If there had been a number here, I would have needed to distribute, but there's not. So I don't need to distribute anything. And then that all equals -2. Combine like terms. 2x plus x is 3x plus 1 equals -2. Subtract 1 from both sides. 3x equals -3. And x equals 1. So I'll highlight that just to make it stick out a little bit more. X equals 1. Plug that answer back into either equation to solve for the other unknown variable. I'm going to choose the first equation because it's already isolated for y and it has a couple less numbers to deal with. So we have y equals x plus 1. Oh, I'm sorry, I divided wrong. -3 divided by 3 is a -1. And then we'll plug that x right in for x. So it's just like another substitution that I'm doing. Y equals negative 1 plus 1. So y will equal 0. And I'll highlight that to make it stick out a little bit more. And my solution, or the point of intersection, is going to be negative 1, comma 0. If I wanted to, I could plug this into Desmos to verify my answer to make sure that it works both algebraically when I solved and graphically. Okay, let's do one more example together, and then I'll let you try the rest on your own. So y equals x minus 2, and 2x plus 2y equals 4. So one of my equations is already isolated for a variable. So y equals x minus 2. I will take everything that x is, and I will plug it right in for y. So then 2x plus 2 times y, and what did y equal? Y equaled x minus 2. And then that all equals 4. Now I have to distribute. Like I said in the last one, I said this would be where we distribute if there was a number here, but there wasn't before. So now I can distribute this 2 to the x and to the negative 2. So I will have 2x plus 2 times x is 2x. 2 times negative 2 is negative 4 equals 4. 2x plus 2x is 4x. We'll add 4 to both sides. That will equal 8. Divide both sides by 4. X will equal 2. And I'll highlight it to make it stand out. I'll take x equaling 2, and I'm going to substitute it back into one of the original equations. I'll pick the first one because there's less numbers, and y is already solved for. And I need to find what my y variable is. So y equals x minus 2. Y equals 2, plug that right in, minus 2. So y equals 0. We'll highlight it so it stands out. And the solution to this system is 2, 0. And if I wanted to verify that my answer was correct, I could type these equations right into Desmos. So let's do that real quick. X minus 2 and 2x plus 2y equals 4. Their intersection point is 2, 0, which is exactly what we got for our solution. So go ahead and finish the rest on your own and let me know how they go.